Hello, welcome to Gentle Lecture Series. In this lecture, we will cover next generation Internet Protocol, which is also known as IPv6. In this lecture, we will study what an IPv6 address is, why it is needed, why the current Internet Protocol addressing scheme, which is called IPv4, is not sufficient, its shortcomings, and in what different categories IPv6 address space is classified. And finally, if you would like to know what is IPv6 address of a laptop or a desktop, we'll also study that as well. Given here are few resources related to IPv6. In case you would like to get your own IPv6 address, which is uniquely reachable, so for India, the authority is called IRIN. It is Indian Registry for Internet Name and Numbers. It is part of DT, Department of Electronics and Technology. You can approach them, pay the required fees, and you can get your own address block. And minimum address block you'll get is about 16 billion addresses. The next three URLs basically gives you good resources on IPv6. The second internet and IPv6 for all are the two good books you can download, read, and they provide you a lot of valuable informations. The next one gives you some tutorials on IPv6, different aspects, and it will be good to refresh and understand where IPv6 is going and what is the deployment path and other details. Let's look at why do we need IPv6. Currently, Internet runs on Internet protocol called IP, whose current version is IPv4. This protocol is running since 1980, almost 34 years. It has served a purpose. Now, the IPv4 address space, IPv4 address is consists of 32 bits, and that means total number of values you can have in IPv4 is 2 raised to power 32, and that means 4 billion. So far, internet access was mostly internet users were trying to access servers, download content, look at it, but it was not so much of a need that anybody would need to reach a specific user. With all this social networking, and now every user is generating their own content, you like to do chat, talk, video calls, running your own stuff, so you should be reachable. So basic requirement for you to be reachable is you need to have your own unique address. Now given the world population, which is about 7 billion, so even if you were to assign one IP address for each person, we would need 7 billion addresses. But IPv4 provides maximum 4 billion addresses, so the IPv4 address space is not sufficient, and we need to have a new addressing scheme that can cover more addresses. Today, each user has probably 3, 4, 5, 10 devices, and you like to be reaching all those devices, so probably need a lot more than 7 billion addresses. So we need addressing scheme that supports more addresses. So this will also bring a question, is all the addresses of IPv4 exhausted? There's no more left. So in fact, the NIC authorities which assign the IP addresses to the different ISPs, they stop giving addresses to the ISPs because they're exhausted. But in reality, more than 50% IP addresses are still not being used. People are just kept preserving it, some are getting wasted, but still, since we can't get addresses, we need something else. There are some methods have been adopted, deployed to deal with the shortage of IP address space. First one is called NAT, or also known as Network Address Translation. So essentially, Internet authorities, or ITF, has reserved three category of addresses, one in the range of 10.0.0.0/8, other is from 172.16.0.0 to 172.31.0.0, and lastly 192.168.0.0 to 192.168.255 or 255. These IP addresses in this range anybody can use in their network. The only thing is these addresses are not routable, not visible on the internet. So anytime you use these addresses, when a packet leaves your edge router, the edge router or edge device will assign a new IP address, which is a public IP address assigned to you by your ISP. So your these private addresses get converted, rewritten as your public IP addresses. So as an organization, you might have, let's say, 5,000 users, but when any of the users goes out to internet, the internet would see only your public IP address and not 5,000 addresses. So by reserving these private addresses to be used publicly but on the internet, this is the most common way which is being used to deal with the address shortages. Other mechanisms used were called classless inter-domain routing. Previously, when IP addressing started, there used to be only three categories, which is large networks. That means they can have each network can have 2 raised to about 24 addresses, medium-sized network which you can have 64,000 addresses, and smaller networks 256 addresses. But there is need that you need to have a network which could require 1,000 nodes or a network that needs 10,000 nodes. So far, our authorities were assigned for those 64,000 addresses, or if a small office network which needs only 10 machines, so you need only 10 addresses, but authority would give you 256 addresses. So those addresses were called Class A, which contains about 16 million addresses, Class B, 64,000 addresses, and Class C, 256 addresses. And as you can see, you get any of those address block, and certainly lot of address would get wasted, because if you get a block of 256 addresses, you are using only 10, you are probably wasting 246 addresses. So to avoid that address wastage space, authority came with a scheme called class inter-domain routing, where you are given addresses as per a requirements in terms of powers of 2, so address wastage is kind of prevented. Other mechanism deployed is dynamic host configuration protocol. That means it is assumed that in a network, in a place, not everybody is active. So whosoever gets connected, power on the laptop, he should get addressed during the connection time. So let's say in an office or organization, you might have total 1,000 users, but you know probably only 100 out of 1,000 would be active at any point in time. So each one would be using DHCP and only get 100 addresses used, so organization can save the addresses. So these are different mechanisms that were used in IPv4 to deal with address shortages, but there are few other reasons that IPv6 were thought to be addressing. That what are the other benefits IPv6 gives, what are the other requirements which IPv4 were not meeting, and there was felt a need for IPv6, and let's consider what the benefit. The few benefits that IPv6 gives you is one is called auto configuration. In IPv4 addressing, either you assign an address manually or there has to be DHCP server, and that requires you need to have some technical knowledge or technical support. But IPv6 does support auto configuration. Means without doing anything, without this thing, just implementing IPv6 network, address can be assigned. Because we have a larger address space, we don't need to conversion from private to public, so we don't need a NAT. From technical perspective, to simplify routing, a number of headers in IPv4 were removed. They were really not needed, and so 6 headers have been removed. That enables faster routing. So possibly if your entire network is IPv4, you might even experience that you're getting a faster response. IPv6 also supports new options, new extensions. There's a built-in support for QoS that was very minimal in IPv4, and of course, in IPv4, security and mobility, that is mobile IP, were afterthought, but both of these are part of IPv6 standard. So that means the moment you have IPv6 implemented, these both IPsec security or mobility are available by default. You need to just configure it and should be working. So let's look at how does IPv6 address works. IPv6 address consists of 128 bits. It is, that means is written in hex digits. So we will write total 32 hex digits. These are written as in 8 groups of 4 hex digits, each separated by a colon. So an example of IPv6 address is 2000 colon 1111 colon 2222 colon 0000 colon 0000 colon 0000 colon 0001 colon 1111. If you look at in this, we have three hex words which are consecutive 0 and there's 0001. We are basically, if we're writing in full form, we need to write full 32 digits. We can write IPv6 in a shorthand notation or in abbreviated form, and if you want to write in abbreviated form, the rules are the leading zeros can be omitted in a word. So like this 0001 can be written as simply as 1. Now there are three consecutive sequence of zeros. We can simply omit it and replace this sequence of consecutive zeros by a double column. So the same above address can be written as 2000 colon 1111 colon 2222 double colon, and this represents continuous sequence of zeros, colon 1 which is shortened for 0001, and lastly 1111. So depending on the number of success zeros, depending on number of leading zeros, informally you can write IPv6 address in a shortened form, and it will save the space and easy to read and understand. But when it gets actually communicated on IPv6 packet, when packet transmitted in the headers, full IPv6 address will always be used. So in actual IPv6 packet, we will still be using full 128 bits, but for reading, for representing, we can use the abbreviated form. IPv6 address is divided into three categories. One is called unicast. That means A is talking to B on one, and so when my destination address will contain address which belongs to only one person. Other address category is called multicast. That means even though I send only one packet, it can be delivered to more than one person. So a group of people, group of machines can be identified as single address, and that is called multicast address. IPv4 has a broadcast address, that means all, but there is no such scheme. It has been merged into multicast. So group of people, if you want to say broadcast is a special case of multicast, that basically means all machine. So broadcast in IPv6 is implemented as a special case of multicast. IPv6 supports one more address type called anycast. That means I would like to talk to one machine in a group. For example, I'm accessing google.com. I don't need to access all servers of google.com, but only one. So they can get only one address, and packet would be delivered to nearest Google server, and that is anycast, which is the new address type which is supported in IPv6. The unicast addresses are further categorized into what is called global unicast and local unicast. Global means you are assigned a unique address in the whole of internet, so you can be uniquely reachable, and if you and this has to be assigned by authorities, possibly your ISP, and all these addresses are identified by first three bits of address space with 001. So address typically will start with either 2000 or 2001 as the first word. Then the local addresses which you can assign yourself. You don't need any authorities, internet authority to assign you the address, and these are more like your private address space in IPv4, like 192.168.1.0 or 10.0.0.0/8 in that range. Further, these local addresses are defined, put into three categories. One is called unique local. That means to an entire organization which may be spanned over multiple geographical locations. For example, if you have an office in Delhi, you have an office in Bangalore and Chennai, and you want to just communicate among yourselves without communicating with anybody in the internet, you can possibly use some local addresses, and that will belong to unique local, that is unique across your entire organization. You can have site local, that means within your Bangalore office, or within Delhi office is some unique local addresses. But since this is part of your unique local addresses, so this is site local has been deprecated. Other category is called link local unicast, which is you just want to communicate within your own office. You don't want to reach anybody. So even if your internet is down, internet connectivity is down, you still need connectivity. Today, if you're in an office and typically your DSCP server gives you addresses, which is also your as a router, and if internet is down, you don't even get addresses with local to the network. And you can't even communicate to two machines, even though you don't communicating internet. So linked local unicast meets that need, that even though you are not talking to outside world, you're not reaching internet, you don't need any authority to assign you addresses. The network can assign addresses by using auto configuration the addresses, and these addresses are identified by first 10 bits as 1111111010, that is in hex form will return as FE80 colon whatever addresses would be. Then of course, like you have a loopback address in IPv4, which is 127.0.0.1. In IPv6, that address is written as double colon 1, and by using that you can reach locally within your machine. If you like to know what is your IPv6 address, if you are using a Linux machine, you can give a command IPv6 -6 and it will display you IPv6 addresses. You can see it shows local loop of addresses double colon 1, Ethernet, which is linked local address and which is started with FE80 colon colon, and the remaining bytes are typically derived from your MAC address. And subsequent lectures we will cover how your MAC address can be used to drive a linked local address without anybody assigning you. If you are using a Mac OS, you can give a command ifconfig your interface name, for example en0 inet6. It will display your IPv6 address. Again, this shows if it is a linked local address, it will start with fe80 colon, and the remaining part would be derived from your Ethernet address. In case you having a Windows, you can give a command called ipconfig, and ipconfig will list out both your IPv4 and IPv6 addresses. You see your linked local IPv6 address is fe80 colon colon, and remaining part is derived from your Ethernet address. So in this way, you depending on the machine, you can find out your own IPv6 address, whether Linux, the Mac OS or Windows, because every OS by default today supports IPv6. So just to summarize, we basically studied what IPv6 address is, what the benefits IPv6 gives us, what are the different ways that, that can address the shortfall of IPv6 address space, and finally we discussed IPv6 addressing scheme and categories unicast and multicast, and unicast further as global unicast and your local unicast. Thank you.